Okay, in today's lesson we're going to be going over balancing chemical equations. Now, we covered this side for notes, so this will just be a quick review. If we look at the very bottom of this chemical equation, the left side is what we call the reactants. They're like the ingredients. This is what goes in. The product side is what comes out. So in balancing, basically what we have to figure out is the number of atoms that go into the reaction have to be the same number of atoms that come out. Although they may rearrange look differently, the number of atoms has to be the same. And the one things, and a part of the structure is that we look at, to balancing, we have to look at the subscripts and coefficients. So subscripts we cannot change, but our coefficients we can adjust to work out the math to make sure that they're balanced. So we're going to go ahead and get started. We're going to flip this over where there's some example problems. We're just going to do a few. Okay, so your page is going to look something like this. We're just going to do a couple on here as examples. So first off, one of the things I'm going to start off with the one right here in the middle, where we have P4 plus O2 yields P4O6. So one of the things I'm going to do is here's your yield sign. Take a line, draw a line that separates the reactant side from the product side. Also, once you get in the habit, is drawing out these lines here in front of each of these for the coefficient to place as we need them. So now we're going to take an inventory. We're going to look at P for phosphorus. There's 4 of them, so write a 4. The other element is oxygen, O. There are 2. So now we're going to compare to the right side, the product side. We also have phosphorus. There's 4 of them. And then we have oxygen as well. And this time there's 6. So right now when we look at, both phosphorus are even. They're balanced, 4 and 4. But when we look at oxygen, there's 2 on the left and 6 on the right. Since we can't take any away, we want to look at what number can we add here that if you multiply it by 2 would equal 6. So knowing our number sense, if we put a 3 there, 3 times 2 equals 6. So then we actually have 6 atoms of oxygen. And we notice, now let's see if we're balanced. 4 and 4, 6 and 6. All right, we're balanced. So then all we have to do in these empty spaces is put a 1 as a placeholder. Because 1 times 4 is 4, 1 times 4 is 4, 1 times 6 is 6. All right, so that one was pretty easy. All right, let's try another one. Let's do the one next to it. We have, let's again draw our line through the yield sign that separates the reactant side from the product side. Let's put our lines out in front so we can put our coefficients. And now let's take our inventory. We have C for carbon. There's only 1 of them. H for hydrogen. There are 2. On the product side, there's only 1 carbon. So the symbol itself implies there's 1. And then for the hydrogen, there's 4 atoms of hydrogen. So again, we're looking at carbons are even, so it's balanced. Our hydrogens are off balance. There's 4 on the right, but only 2 on the left. So what number can you put here? If you multiply by 2 it equals 4, well, we're going to put a 2 there. So 2 times 2 equals 4, so cross that off. So now we compare side by side. We are balanced. Carbons are 1 and 1. Hydrogens are 4 and 4. Empty spaces get 1s as placeholders. Okay. All right. We'll do one more. It might be a little bit more challenging, but sometimes they look harder than what they really are. So let's do this, the one right below it. All right. So put our lines out, draw our line that separates reactant from product. Put our lines out in front for our coefficients, and let's take our inventory. All right, Fe stands for iron. There's only 1 atom. Hydrogen, there's 2 atoms. Oxygen, there's only 1. Now, my suggestion when we do the right side, try to keep them side by side. So if you look at iron here, that's the first one we'll do. There's 3 of them. Oxygen is the next one, but I don't want to put it next to hydrogen. I want to put oxygen next to its partner. So for oxygen, I'm going to write below, there's 4, and then hydrogen, there's 2. Alright, so now we have to go ahead and balance. Alright, first thing that you can do is we can look at if there's 3 hydrogens on, look at our irons. If there's 3 on the right, we need to get 3 on the left. So all we need to do, so what number times 1 equals 3? Well, 3 times 1. So we'll put a 3 there. 3 times 1 now gives you 3. Our irons are balanced. Our hydrogens, 2 and 2, are already balanced. So what's next? Let's balance our oxygens. So you have 4 on the right, but only 1 on the left. So we're going to add a 4 to this side. So this is what happens. So we're going to put a 4 here. But we have to distribute this 4 to everything. So 4 times 2 hydrogens gives you 8. 4 times 1 oxygen gives you 4. So our oxygens are even, 4 and 4. But look what happened. We now have 8 hydrogen. Our oxygens are even. We have 4 and 4. But our hydrogens change. We have 8 on the left, but only 2 on the right. So what number can we add here to get 8 hydrogens?